There's a random function that's built into C++ that returns a value between 0 and 32,767. Many times, actually most times, we want a random number between certain parameters. I'm going to call those parameters the lower bound and the upper bound. And let's say, for example, we want to produce or simulate the roll of a die. In that case, we have 6 values, 1 to 6. In that case, our lower bound is going to be 1, our upper bound would be 6. If we were looking for numbers between 1 and 100, then that would be, the lower bound would be 1, the upper bound would be 100. The C++ statement would look very similar to this statement right here, where we've declared a variable, and then we use the random function. We modulate it with the total number of options that we want. In this case 6, because there are 6 values, and we need to add 1. A lot of students ask, why do we need to add 1? And hopefully by the time that we've finished this little spreadsheet, you'll completely understand how we apply the random function and why we need to add the 1 and how it can be useful to you in getting other value ranges. One note of interest, just like in other programming languages, you can name regions. I happen to have named this cell in particular upper bound. And the reason I've done that is because I want to be able to change that value. So I've given us a list of random values. Starting at the lowest value that could be returned to is 0, incremented to 100, then 1,000, then 10,000. At 10,000, I give us a range of continuous values. And then finally, I give the top value that would be returned by the random function, 32,767. So the first thing I really need to know in order to find the remainder, which is what the modulus function does for us, I'm going to do this in baby steps just so you can see exactly where the numbers are coming from. In order to determine the remainder, I really have to know how many times my number will go into the number that's been randomly generated. So in this case, I'm going to take the integer value of column A divided by my my upper bounds random number. In this case, that works because I've started at 1. And I'm just going to carry that formula all the way down this column. As you can see, 0 won't go into 6 evenly, but 6 will go into 100 evenly 16 times. Now, in order to figure out what remainder I have, I actually need to figure out how many I've accounted for out of the 100. So what I'm going to do here is I'm going to take my upper bound, which in this problem is 6, and multiply it by column B. And I'm also going to carry that formula out throughout the column. Now, what this tells me is that 6 will go into 100 16 times, and that accounts for 96 of the 100. So that I then have a remainder of 4. And this is actually the value that will be returned by the C++ modulus function. Again, I'm going to carry the formula down. Now here's what we see. If the random value 100 is generated, and I'm looking for a value of 1 to 6, by using this particular formula, I'm going to get a 4. What's happened is it's taken the entire range from 0 to 32,767, and it split it up into 6 equal or fairly equal partitions. And by determining which range the remainder falls in, that gives me the number that I can use to simulate a die roll. But there's something odd about this column, and that is that it runs from 0 to 5 rather than from 1 to 6, which is what I want. Herein lies the reason we have to add 1. And as soon as we've done that, we actually get the range we're looking for from 1 to 6. Notice that the continuous range that I specified, you can really see in the final column how those continuous ranges are affected by the remainder. So basically each number will tick up 1, and then your upper bound will roll back to your lower bound. If I want to change the lower bound to, say, numbers from 1 to 10, the way I've set the spreadsheet up, it just simply plugs the numbers in for me. So now 10 will go into 10,000 evenly 10,000 times. So there's no remainder. So the number that I would get returned into my variable would actually be a 1 using the formula that we've used above. And you can see that it runs the numbers from 1 to 10. I can even put 100 in here. Basically any number up to the 32,767 I can put in my upper bound before it will blow out my formula. And then if I want a number greater than that, I'm going to have to play some different games. But I've chosen not to explain those here. Now, this is just giving us a basic number between 1 and some upper bound. But many times you may have a lower bound that doesn't start at 1. Perhaps it starts at 25. Using this base formula, you can improve your code so that it's all on one line if you like, or simply add a few more lines to figure out how many items are in the particular range that you're looking for. And then you should be good to go. So this has been a short tutorial on how to use the random function in C++ and just exactly what it means.